This video is on the electric field intensity on the equatorial axis of a dipole. On the equatorial axis of an electric dipole. Suppose we have an electric dipole as represented in a diagram by AB. O is the midpoint of the dipole. We are representing the total length of the dipole by 2L. So the distance from A to O will be L, and from the point O to B, O will also be equal to L. So let the distance of this point P from O be R. Since the point is on the equatorial axis, so the angle POB as well as the angle POA will be 90. Now we join A to the point P, and similarly we join the point P to the point P. Now the distance PA will become equal to under root R square plus L square. Now similarly distance PB will also become equal to under root R square plus L square. Now if at the point A we have the plus Q charge, at the point B we have the charge minus Q. Now the electric field intensity due to the charge plus Q will be directed outwards. Say we are denoting that by EA. And similarly the electric field due to the negative charge minus Q will be directed towards the charge minus Q. Now if I draw the horizontal and vertical axis from the point P, I am representing the horizontal axis by Px, vertical axis by Py. Now if the angle PAB with theta, and if I take this point to be Z, then ZPX will also be theta, being corresponding angles. Similarly, if the angle PBA be theta, and this is theta because that angle APB is a isosceles triangle. So the angle XPB will also be theta, being alternate angles. Now this electric field EA is acting at an angle of theta to the horizontal. So it will have two components. One is the horizontal component, that is EA cos theta. Other is the vertical component, that is EA sin theta. Similarly, the electric field EB, it is also acting at an angle of theta to the axis PX. So it will have two components. One will be EB cos theta, which is along the x-axis, and the other will be EB sin theta, which is the along y-axis. Now, first of all, before seeing the horizontal and vertical components, we will see what is the value of EA and EB. We know that the electric field intensity due to a point charge is given by 1 by 4 epsilon 0 Q upon R square. So we can write the value of EA as 1 by 4 epsilon 0 Q divided by under root of R square plus L square whole square. And that will come equal to 1 by 4 epsilon 0 Q upon R square plus L square. Say this is equation number 1. Similarly, the value of EB will become equal to 1 by 4 epsilon 0 Q upon, again the distance is same, PB and PA are same, so that will become under root R square plus L square whole square, which can be written as 1 by 4 epsilon 0 Q upon R square plus L square. Now it is clear from the equation number 1 and 2 that the value of EA and EB are equal. So we can write that EA is equal to EB. Say this is our third equation. Now we want to find the resultant electric field E at the point P. Since electric field intensity is a vector quantity, so we will have to first of all calculate the total horizontal component, which is EX. So that will be equal to EA cos theta plus EB cos theta, as EA cos theta and EB cos theta are in the same direction. So EX will be equal to how much? 2 into EA into cos theta. So this is our equation number 4. Now similarly, what will be EY? Since EA sin theta and EB sin theta are oppositely directed. So that will become equal to EA sin theta minus EB sin theta. And as from the question number 3, it is clear that EA and EB are equal. So these will cancel. And we will get EY is equal to 0. So the value of EX is 2EA cos theta. And the value of EY is 0. Now the net electric field E will be equal to under root of EX square plus EY square. Why? Because EX and EY are because EX and EY are at an angle of 90 degree with each other. Now if we substitute 0 instead of EY, because the value of EY is 0. So we can write, so if we substitute EY is equal to 0, we will get E is equal to EX. And the value of EX is known to us, that is 2 into EA into cos theta. From the triangle, we can see that the value of cos theta is base upon hypotenuse. Base is L. Hypotenuse is under root R square plus L square. So the value of cos theta will be L upon under root R square plus L square. And the value of EA was equal to 1 by 4 epsilon 0 Q upon R square plus L square into L upon under root R square plus L square. So the value of E will become equal to 2QL divided by 4 pi epsilon 0 R square plus L square to the power 3 by 2. And we know that the value of 2 into Q into L is P, which is the dipole moment. So the formula for E will become 1 by 4 epsilon 0 P upon L square plus R square to the power 3 by 2. So this is the formula for electric field intensity on the equatorial axis of a dipole. The distance at which we want to find the electric field is very large as compared to the length of the dipole. Then E will become equal to 1 by 4 epsilon 0 P upon R cube. So this is the formula for the electric field intensity on the equatorial axis of a dipole. If we compare this formula with the electric field intensity on the axial axis, it will be observed that this is half the electric field on the axial axis.